Thank you for joining us for the first session after the keynotes. My name is Andy Moy, and I'm joined by my colleague Vlad Vlastianu. We're solutions architects down in the Southern California territory. So welcome to Deep Dive into blue-green deployments on AWS. So deploying software has its challenges and risks. So we're here to help you mitigate those risks through the use of blue-green deployments. So you'll see examples of common blue-green patterns and learn to leverage the automation capabilities of AWS to streamline your deployments. The data tier is a crucial portion of your application, so you'll learn some best practices and considerations for how to handle those during your blue-green deployments. And of course, we want to make sure you're doing this as cost-effectively as possible. So the concept of blue-green is not new, but it's not commonly seen in traditional environments. And that's mainly due to the cost and effort required to provision the additional resources. So as you think about your deployments, you want to try and favor solutions that will reduce downtime, handle dependencies, and be able to coordinate your workloads a lot better. So this list may not be a surprise to any of you, and you may have spent many nights and weekends dealing with these failures and issues. So through the use of blue-green, we want to help you mitigate these risks. So let's talk about how blue-green, coupled with AWS services and tools, can help in these situations. So the idea behind blue-green is simple. You have your blue environment, which is your production environment carrying live traffic. And in parallel, what we're going to do is provision this green environment, which is identical in nature, only it's running a different version of your code. The deployment aspect is simply being able to route your production traffic from the blue environment to the green environment. And if you encounter any issues along the way, you have the ability to roll back quickly and easily. So some examples of the traffic switch capabilities, you can use DNS and load balancing, and you'll see this in the patterns as we progress through in the presentation. So looking at the blue and green environments, we're going to refer to environments quite a bit throughout the presentation. And we define environments as where things have changed and what you need to do to make those changes live in production. So for example, this could be a small component of your application, or it could be as wide as a full tier of your application. So here are just some examples of tools in the AWS ecosystem that you can leverage to help scope your environment. So for example, if you're a type of organization that operates a golden image, you can use golden AMIs and deploy those out into production using things like auto-scaling groups. Now on the other end of the spectrum, you've got a wider scope, which is with AWS CloudFormation. So with AWS CloudFormation, you're able to describe all the AWS resources you need for your particular stack. And this could be anywhere from networking to EC2 instances, security groups. And with CloudFormation, you can coordinate the deployment of multiple services at once. So as you think about how you scope your environments, you want to think about your software development lifecycle. Think about the goals of your organization, current and even where you want to be down the road. So things like your application architecture. Are you tightly coupled? Are you loosely coupled? These will factor in which tools you want to use for your particular case. At the organizational level, you want to think about, OK, am I the type of organization that deploys very frequently? Are you deploying daily? Or maybe you deploy every 2 weeks. From a risk and complexity perspective, you want to think about the effect of your changes. Do you augment your process based on whether it's a minor or major version, or maybe it's a simple patch to your application? There's a lot of variance. That's the overall point, right? And you want to look at these factors to basically pick the right tool for the job. So it is possible to do blue-green in traditional on-prem environments, but there's a lot of heavy lifting, a lot of capital expense, and there's a lot of capacity planning to really do it well. And with AWS, you have a breadth of services, you've got a utility-based billing model that allows you to move fast and cost-effectively implement blue-green patterns at scale. So with that, I'll turn it over to Vlad, who's going to launch into the patterns that we'll talk about on AWS.
Hey, thanks, Andy, and welcome, everybody. So when we're talking about blue-green deployment patterns on AWS, a couple of things to understand is that there's really not a one-size-fits-all kind of solution, right? So what you want to do is, and what we've prepared today here, is a couple of patterns that illustrate very well the type of considerations around environment boundaries that Andy was talking about, and the type of considerations around risk mitigation. But before we go on, so what you'll see here is 6 patterns that we've picked up that we see most commonly implemented on AWS. And top to bottom, you'll see that the environment boundary gradually gets narrower, right? You're starting for something that might be a full application tier and going down to something very specific, much more granular. And left to right, you'll see commonalities between patterns that affect architectures where you deploy around with instances versus container-based architectures. So let's start. There is a common thread around all these, and that is your environment automation. When you're looking at those deployment risks that Andy kind of talked briefly about before, you'll notice that some of them, such as the human error risks, the infrastructure failure risk, the deployment process risk, they're not necessarily mitigated by the deployment pattern itself. They're more mitigated by the strength of the automation platform that you're choosing. So something like CloudFormation is the most comprehensive automation platform you can use. So you can deploy stacks really from nuts and bolts, from the networking configuration all the way up to the software configuration. And furthermore, you can use something like CloudFormation to control higher level automation services, such as Elastic Beanstalk, or the Elastic Container Service, or OpsWorks, or auto-scaling, or you can even roll your own. And the key is to take advantage of these automation platforms as much as possible to mitigate your deployment risks. So with that in mind, let's look at what is probably the traditional blue-green deployment pattern. So in this example, we're starting with a current application. We call it the blue environment, right? For illustration purposes, I picked up Elastic Beanstalk, right? You can do similar with OpsWorks or rolling your own automation framework as well. And we've picked up a web tier environment for Elastic Beanstalk. Now, on purpose, I left the database and the data tier considerations out of the environment. We'll address this a little bit later. And you also have a DNS endpoint at the top that resolves to your load balancer of your web tier. So when we're starting the deployment, we're deploying a new version of the application, a new Beanstalk environment. We call it the green environment. And then we start trickling some traffic over there. That gives us the ability to test the green stack. You might choose 1%, 10%, or you might do even some testing before you even start trickling in production traffic. What this gives you is, what we call this is canary analysis. So the idea is to test ahead of shifting a large load of your traffic over to your new version. That gives you the ability to test the functional aspects of your application and gives you the ability to start testing the performance of it. And we continue to gradually test traffic and cut over traffic while we're monitoring the environments to ensure that they're operating correctly. The performance meets expectation as you're increasing the load on your green environment. Now, if something breaks, all you have to do is switch things back, turn the dial the other way around, and shift traffic back to the blue environment. And what that gives you is essentially it limits your blast radius during the deployment process, because only a portion of your users will be affected, and ideally it's going to be a very small portion. And then finally, we're all fully sending all the traffic over to the green environment. And then we can dispose of the blue one and stop paying for it. Now, from an automation perspective, we can use CloudFormation to model this entire environment and deployment. Have an example, a really high-level template over there. We package the application, the blue application version, the blue environment resources, the blue DNS endpoint, all of them into a single template. We can version control this template. We can add all the supporting resources, such as VPC, subnets, security group configuration, IAM roles. All of those can be captured into the same template and version controlled as you're changing your environments. And we can use higher level services, like in this example, OpsWorks or Elastic Beanstalk, and model those with our CloudFormation template. And then when we're ready to launch the green environment, we simply update the template, add the green resources to it, and then update the CloudFormation stack. And CloudFormation will provision all those green resources for us. The key question then becomes is how quickly can you shift traffic over? Now, we talked about Elastic Beanstalk. It has a very simple swap environment feature where you just flip the DNS endpoints. It's simple, but it's all or nothing, right? It doesn't give you the sort of canary analysis ability or the ability to control the traffic very well, right? So what we want to do instead is use Amazon Route 253 weighted DNS switching. And at that point, we can have a granular control over our traffic switch. One thing to keep in mind, though, when we're dealing with DNS is we need to factor in the DNS time to live. So that is essentially the amount of time your DNS client will cache the results of a DNS query until it asks the upstream DNS servers for updated IP addresses, right? So that builds up a reaction time, which is the time to live times the number of DNS caches that are in your path, plus the Route 53 propagation time, which means that realistically, even if you make a switch, the traffic is not going to be flowing instantly according to the weighting that you're giving it, right? And the other aspect of it, you might have legacy DNS clients or misbehaving clients that completely ignore your DNS caching specification. So at that point, really, that means that when you're shifting traffic to your green environment, it's going to be slower than, and there's going to be a delay between when you change your weighting and when you see the traffic switching. On the flip side, if you have a rollback need, doing the same thing back, it's also going to take some time, and there's going to be some complexity there. So you got to factor that in. Additionally, you got to factor in that if you use auto-scaling and ELBs, those need time to scale out. And you need measurable metrics to actually keep track of the health and the performance of your deployment. Things like at the load balancer level, the latency gives you an idea of the type of user experience your customers are seeing during the deployment. The surge queue length will tell you how many requests are queued up at the load balancer waiting to be serviced. If the queue grows too much, you're going to have a spillover where the load balancer stops actually accepting those requests, right? And then you have to look at the backend connection errors to have indications as far as how your backend servers are behaving. Are they overloaded? Are they scaling at the right rate? And finally, you also may have your own application metrics and your own deployment goals. So taking a little bit look and combining those two together, let's look at the automation piece. This is a kind of an expanded view of the DNS endpoint CloudFormation snippet. You'll see that we have a weighting there, part of our stack, part of our different blue and green endpoints. And you're going to start with an initial weighting information. But really, for simplicity, I hard-coded the values in. When you're actually doing the deployment, you probably want to use template parameters, right? So you don't have to update the template every time you shift the traffic over. You want to just use parameters and then use the same template and just update the stack. So let's see how this stacks up. So it's great for mitigating risks around the application issues, around application performance because of the gradual nature of the traffic shift, because of the fact that you have canary analysis. People and processors, infrastructure risk, those really depend on your automation platform more than anything. At that point, if you use something like CloudFormation or Elastic Beanstalk, you can significantly improve your risk mitigation on those as well. But from a rollback perspective, there's a weak spot there because you have to deal with DNS time to live complexities. So let's remove that out of the solution. The next pattern is similar, but what we're doing is we're taking the load balancer out of the environment boundary, right? So the load balancer is not part of the environment boundary, is not part of the deployment, remains fixed. And instead, we're narrowing the environment boundary to the auto-scaling group. So the deployment involves just essentially provisioning a new green auto-scaling group in addition to the blue one. Now, you probably won't be able to use Elastic Beanstalk in this example. We're actually controlling the load balancer and auto-scaling groups directly in this case, but you can still deploy this using CloudFormation. So we start with our current blue auto-scaling group. We deploy and scale out a new green auto-scaling group, and we test the stack. At this point, you can use a secondary load balancer to test for functional issues. And then you register the green auto-scaling group with the same load balancer, and it will start receiving traffic immediately. And then you start growing that auto-scaling group until you reach desired capacity, and you start removing instances out of the blue one. Now, there's two ways you can do that. You can either scale in the blue auto-scaling group, which will terminate instances, or you can take them. You can use auto-scaling standby feature to take those instances out of the current processing, place them into standby. That way, they're still there. They're not receiving traffic, but if you need to roll back, it's a quicker rollback. So finally, when everything is done and all your instances are decommissioned, you can remove the old auto-scaling group. So how does this work? So this relies on very specific behaviors around auto-scaling groups behind load balancers. So when you have a load balancer, you can register one or more EC2 instances with it, and you can register one or more auto-scaling groups with it. Elastic load balancing also uses a least outstanding request algorithms, which by default will favor your green auto-scaling group. The moment you actually register that auto-scaling group with the load balancer, those ELB will start sending traffic to those instances, and it'll continue favoring sending requests to those instances until kind of the overall level of requests on all your instances, blue or green, is about even in that. And it also has connection draining capabilities. So you stop gracefully receiving requests on your blue instances as you terminate them or as you take them out into standby. That means that it's a better user experience, a better end user experience. You want to, of course, make sure that you scale out the green auto-scaling group before you register it to the load balancer. And we talked briefly about putting instances into standby. So the idea is, as the example command over there, is when you take an instance, put it into standby, the load balancer will stop sending traffic to it. The auto-scaling group will shrink by the number of instances you're placing into standby, but the instances are still running. So in the event of a rollback, you can always take them out of standby and put them back into the auto-scaling group, and you don't have that delay of the auto-scaling provisioning new resources, which might entail configuration of your application on your side. So it's a faster rollback that way. So reviewing kind of how this pattern works, it's great at detecting application issues. It also handles application performance very well because you can manage the traffic split, but it's less granular. Realistically, your traffic split is going to be handled by a unit that is your instance, by how many instances you add or remove. So your granularity level is going to be the instance in this case. It's also great at managing infrastructure failures due to auto-scaling, and we don't have the DNS complexities to deal with. Okay, so let's reduce the environment boundary even further. So at this point, we're swapping launch configurations. So the launch configuration, for the folks that don't know what that is, it's essentially a blueprint that autoscaling uses to spin up new instances and add them to the group. So each autoscaling group has exactly one assigned to it at any time. So when you substitute it, any new instances that get provisioned will be provisioned by using the new launch configuration. So we do exactly that. We swap out the launch configuration with a newer one corresponding to our green application version. Then we scale out the auto-scaling group to essentially twice the size to ensure that we have enough capacity on the green side to handle your load. And then we start shrinking back the auto-scaling group once that's done and start removing instances out of it. Now, auto-scaling will generally remove instances with the oldest launch configuration first, which is what makes this work and which is reducing your blue application environment footprint. And again, we can always take those instances out and place them into standby. And once we're done, we have only green instances left in our auto-scaling group. So let's talk a little bit about launch configurations. So there are blueprints that auto-scaling uses for instance provisioning. When you scale out or replace failed instances, it will use whatever the current launch configuration you have specified for that group is, which means it makes it work with the green one. But when you scale back in, it will remove all the old ones, oldest launch instances with oldest launch configuration first, but it will also try to keep the capacity in all availability zones that you're operating under even. So if you're starting with a fleet that's uneven, where you have more instances in one availability zone than in the other ones, there's a chance that auto-scaling, in that desire to keep everything even, will terminate some of your green instances too. So if you have uneven fleets, you might need to handle that manually by either compensating, by adding new instances or removing manually old instances to keep that even balance. And like I said before, we can temporarily remove those instances from the auto-scaling group. From a review perspective, this pattern, there's some complexities around detecting of errors in your applications or performance. Because you have a heterogeneous fleet, you end up with an auto-scaling group that has instances with blue, from the blue environment, and from the green one. So at that point, you have to rely a lot more on your application level metrics to detect errors and detect performance issues. And you want to correlate that to infrastructure metrics to find out where those issues are, what they are, and how to compensate for those types of things, or whether you need to do a rollback. It's great, on the other hand, for rollback capabilities. It does give you a couple of options there. For example, you can put instances back into standby if you've used that method, or you can just configure a new launch configuration and go through the whole deployment process again. So there's a couple of options. On the other hand, from a cost perspective, because you initially scale out to essentially twice your size, from a cost optimization perspective, you're going to be over-provisioned for a little bit longer than compared to the other methods that we discussed. And now Andy's going to talk a little bit about the patterns around ECS container service.
All right, thanks, Vlad. Okay, so what if we're running containers? So Docker containers are great because they preserve the fidelity of your environments, whether they start at your developer workstation and make their way into production. So the patterns that I'm going to talk about will illustrate how to take these containers and deploy them out into a fleet of EC2 instances, which we'll call the container instances themselves. So the two things to be mindful of here is we're going to reference task definitions. And task definitions will declare your resource requirements and identify the container version that you'd like to deploy. And the other concept is the ECS service. So the ECS service will essentially prepare a long-standing process. It'll deploy tasks to your container instances and watch out for the health of these running containers. All right, so the first pattern we'll talk about takes us back to the classic DNS pattern. So here we're going to be shuttling traffic from a blue ELB endpoint to a green ELB endpoint. So here you see you have your ECS service, we'll call it the blue environment, made up of a task definition and an ELB endpoint. What we'll do is we'll create a new ECS service, the green ECS service, register a new task definition, create a new ELB endpoint, and associate it together with the ECS green service. When it's time to deploy, we simply update the Route 53 alias record to route the traffic from the blue environment to the green. And note here that we're actually doing a full cutover. You could still do the weighted DNS that Vlad had talked about earlier. So once you've determined that the green environment is live and functioning properly, you can remove the blue resources, or you could use it to stage the next version of your application, depending on how quickly you push changes out. So Vlad had illustrated how to do this with CloudFormation. I'm going to take a different approach and illustrate it with the AWS CLI tool, which will update the ECS service as well as your Route 53 alias record. So the first step we'll take here, we're going to register a new task definition. And as you can see, we pass in this JSON object on the right. And you'll see the image we're referencing a version 2 of the Docker container. In the second step, we're going to create your ECS service. And it's going to be a green ECS service, web service version 2. We're going to load in the task definition that we created just before. And we're going to reference the load balancer endpoint, specially designed for the green environment. And then the third step, we'll update the Route 53 record to update your target for your alias record to point to the green ELB. So just to review this pattern, the application issues are detectable because you can do either a full cutover or you can do the weighted canary analysis as well. So you can take your time with this approach and really test fully and be sure that your applications are running as expected. From an application performance perspective, you're dealing with a fully scaled up green environment. So you have all the same amount of containers deployed into your, across your fleet. The only thing to be mindful of, you want to make sure your ELB is warm. So since you haven't introduced any traffic, if you do a full cutover, you may want to call in support and have them pre-warm your ELB for you. That way it's prepared to support the production traffic. Alternatively, too, with ECS, you can actually auto-scale your ECS service, the amount of tasks that are deployed into your environment. So if you haven't checked it out, we actually released a blog entry that talks about how you can tie in CloudWatch metrics to your ELB performance and use Lambda to essentially update your desired task count for your ECS service. From a people and process perspective, we're dealing with just a simple DNS switchover. So it's a quite simple process. And again, you can take your time throughout your release process. Infrastructure failure isn't necessarily mitigated by the pattern. So what we recommend is to use either CloudWatch metrics or use an auto-scaling group to manage the fleet size and the health of your fleet altogether. From a rollback perspective, we're dealing with DNS, so you do have the same complexities that Vlad had talked about earlier. And the later patterns that we talk about will introduce ELB, and it'll be a better rollback capability overall. And for a cost perspective, we're dealing with two fully scaled up environments. So the resource requirement for your container instances is essentially double. But again, this gives you the ability to fully test out both your new green environment. All right, so going on to the second pattern. So this pattern is going to be very similar to the first. The only major difference is we're going to leverage the same ELB endpoint and allow load balancing to essentially migrate the traffic from the blue environment to the green. So again, we're going to start out with a blue ECS service. We're going to register a new task definition that's going to identify the new container image. And we're going to loop this in with a new green service, only this time we're going to leverage the same ELB. So once the service is deployed into the environment, you can incrementally scale up the ECS service by updating the task count. And you can also decrement the blue ECS service when you're happy with the green service's performance. So you have very granular control how you scale up the green environment and how you scale down your blue environment. So you've already seen how to register a task definition in the last step, so I'll just focus on the create service aspect. And again, we're creating a new service, registering the new task, referencing the new task definition, and this time we're going to reference the blue ELB that's already in production. And also notice that the desired count is at 1. So we're going to slowly introduce the green ECS service into the environment and test accordingly, and then scale it up and scale down as necessary. So you can use the ECS update service call to scale up the green service, and then you can reduce the blue service to the desired count of 0 when you're ready to decommission the blue. So this is very similar to the swapping of ASGs behind an elastic load balancer. Now, since you are going to have coexisting versions, just make sure your application can coexist. So reviewing this pattern, application issues, again, canary analysis, it happens by default. So you have the ability to fully test and migrate at your own pace. Looking at application performance, you're dealing with an already warm ELB. So this gives you the benefit of being able to just perform your deployments, not have to worry about calling support and scheduling the pre-warm. And again, you can look at scaling your ECS service using the CloudWatch metrics and Lambda capabilities I spoke about in the last pattern. From a process perspective, it does involve a few more steps because you have to scale up and down the green and blue environments. But again, this does give you more granularity in terms of your traffic switch. Infrastructure failure, again, you want to use CloudWatch metrics and auto-scaling groups to manage your ECS fleet. And the rollback, since we're not dealing with DNS and we're letting ELB essentially take over, it's very convenient, and the rollback capabilities definitely excel compared to the last pattern. Now with ECS services will take care of the registration and deregistration of tasks from your ELB automatically. When you actually go to set up your ECS service, you'll see that you can reference the ELB endpoint, and it has the IAM roles to essentially update accordingly. From a cost perspective, you don't necessarily need a full environment to run both services, and you can incrementally scale up and down accordingly, and it'll naturally decommission blue resources and replace it with a green resource. So this final pattern actually highlights a built-in capability for blue-green deployments with the ECS service. And this is going to accomplish this essentially by replacing the task definition for the ECS service itself. So you start with your blue task definition, which is in your current ECS service, and you're going to create a green revision of that same task definition. Now to start off the deployment, you're going to update your ECS service, and it will naturally deploy the task definition to an available container instance. Now remember, in order for this pattern to work, you need to have at least one available container instance. Otherwise, ECS will essentially wait around for a new resource to pop up. Once you have that green task deployed, it will, in a rolling fashion, continue to deploy the green resources out, and it will slowly deregister and drain the connections from your blue task definition. So here we're going to focus on the update service again. Here you're going to reference the new task definition that you created, which will be the green revision. And note it has a very generic name. We call it web tier. Now ECS by default, if you create a task definition of the same name, it will naturally create a new revision, and it will manage that for you. So if you do an update, it will always choose the latest revision of the task definition unless you mention otherwise. So after you've issued this update service command, you can use describe services to monitor your progress. So here in the output, you see there's a services section that references the new green task definition that we've created. And you can see that it has web tier :2, which is indicating the second revision. Also important in the output is the deployment section. So here you'll actually see that there are multiple deployments in play. The green task definition is marked as primary, meaning ECS will respect that and slowly issue that out into your container instances. And you see that the blue task definition is still marked as active. Also important in the describe services section is the events. So here you can, as you do your update, you can monitor for any sort of errors. You can also see the process as it registers new tasks, deregisters tasks, and determines when your task is at a steady state. So looking at this pattern, we see that from an application issues perspective, you don't necessarily have the same canary analysis capabilities. But if you're going to be pushing a lot of changes very frequently, this may be a moot point, and this may benefit your organization's pace a lot better. From an application performance perspective, again, you're dealing with an already warm ELB. Even though you don't have the granular traffic management, ECS handles that for you. Process perspective, ECS automates the deployment of the new task definition out into your container environment. So it's very easy and very convenient. From an infrastructure failure perspective, again, use CloudWatch metrics and autoscaling to essentially manage your fleet. Rollback, no DNS, ELB, and ECS automates the whole thing, so it's very, very quick for rollback capabilities. And from a cost perspective, you only need +1 resource from a container instance perspective in order to kick off this whole process. And ECS will manage the whole rolling deployment process for you. So with that, turn it over to Vlad to talk about your schema changes.
Yeah, thanks, Andy. So until now, we deliberately only talked about kind of stateless services, so services that don't maintain data, don't store any data. But what happens if you actually have to manage and do a blue-green deployment that factors in state changes, or you have to do factors in databases, or you have to do a schema change, right? So the easiest way to do it is, and the process that we see most commonly implemented is to decouple the schema changes from your code changes. Realistically, really, this means that the database is outside of your environment boundary and not strictly part of your blue-green deployment, right? And you have two options. You either make the database and the schema changes first, and in that case, the database itself, the old code needs to use the new schema, so you want to make sure that it's backwards compatible. Or you can make the schema changes at the end after the blue-green deployment completes. Means that your green application has to have backwards compatibility to be able to talk to the old database for a while. And realistically, if your changes are more complex, you might decide to combine those two methods together and have some schema changes at the beginning and some schema changes at the end. Now, there's a trade-off there. You buy simplicity for increased deployment risk because, if you make the changes to your schema, right, and then your application doesn't work with the new schema, that's bad, right? So what we want to do is, in this kind of a situation, this puts a significantly more emphasis on your software development lifecycle before the actual production deployment process itself. So if you have a strong testing phase, a strong QA phase that weeds out some of those issues around around potential schema issues, and you're testing your applications beforehand, well, you can mitigate this risk significantly. So this is great because you have to only work with a single database and all the environments talk to the same database. But what if your schema changes can't be decoupled, right? Or you're deploying across regions where your blue environment is in one AWS region and the green environment is in another AWS region. So realistically, in that kind of a scenario, your database tier is going to be inside your environment boundary. It will be part of your blue-green deployment. So each one of those environments are going to have their own data stores. And you need to coordinate data changes across the stacks because your blue environment needs to have the most up-to-date data just in case you need to roll back. And your green environment needs to have most up-to-date data because it's going to become your new production environment, right? And at that point, you also have to factor in consistency. So if you're dealing with data replication and data synchronization, if you have an eventual consistency model in your data, that's going to help things significantly. So here's an example of that, a very generic pattern. What we do is we have an aggregator of central write operations, right? So instead of each environment during the deployment process talking to their own database, they're going to talk to a central queue, for example. This can be easily implemented with something like Elastic Beanstalk with a worker tier. And there's a worker application behind that queue that takes those changes and pushes them to the databases of each environment in their own schema formats. Now, there's a couple of things you need to factor in when you do this. First of all, you need to start with a common set of data, a baseline set for both environments. How you do that depends on the type of database that you're using, right? So if you're using something, for example, Amazon RDS, you can use snapshots, you can use cross-region or read replicas to actually achieve that common set of data initially before the deployment starts. Or if you use DynamoDB, you can use update streams and our cross-region replication applications to make sure that you have tables that are in sync and have the same data on both sides. And you have to actually factor in your application some kind of flag that switches and tells the application to, okay, now we're starting a deployment. Don't talk directly to your database. Talk to that central rights aggregator for the duration of that deployment. So it has some, internal, code changes that need to be done. And of course, you have to account for data lag and latency and things like that. Now, the good news is that you can simplify this some in certain situations. So you can have your green application, for example, write to both databases, right, during the deployment process. And then you'll have an asynchronous process that moves your data changes from the blue database that the blue application made to your green database as well. Now, this is great if there's a mismatch in consistency requirement. For example, your old application version is older, has needs for strong consistency, but your new application doesn't, right? It's tolerant for eventual consistency. Another option is to just let each application write to its own database, right? And be completely isolated, completely independent. There's no code changes that you have to do to factor in the deployment process itself. And then essentially that centralized system that aggregates the writes and pushes this through, you're pushing it down a level, and it's asynchronous, it's behind the scenes, where it takes the changes from your blue environments and pushes them to the green one, takes the changes from the green one and pushes it to the blue one. It allows you to fully decouple your blue and green environments. An example that I have here is achieved using DynamoDB tables with streams and triggers and Lambda functions. For example, you have a blue application that talks to a DynamoDB table, a blue one, Dynamo-specific table, that publishes a stream that gets read by a Lambda function that applies the same changes in your green table that is associated with your green stack. Now, the opposite flow obviously also has to be implemented similarly. And you don't have to necessarily use DynamoDB. You could potentially achieve similar stuff with, if you're using third-party databases, some of their toolings around, consider database triggers, for example, for relational databases, or a custom application as well. So in summary, what we've preferred this diagram here, so we can show you kind of how these patterns stack to each other. The key takeaway here is not that necessarily one of them is worse or better than the other, right? The key takeaway is that some of these patterns may apply to certain use cases and certain workloads better. You know, you might be fine with the simplicity of DNS switching in certain scenarios, especially if you don't do deployments very frequently. Or if you do them very frequently, you might want something that doesn't have to factor in all the complexities around DNS time to live. And finally, there's always going to be risks associated with deployment, so you want to mitigate and control those, right? We talk to customers and we hear the story a lot where, you know, customers are afraid of deployments or they're shying away from them. And the idea is it becomes a vicious cycle, you know, because you delay deployment, you accumulate more changes. Because you have more changes, the risk of that deployment and complexity of it increases. And that makes you postpone deployments even more. So you end up in that kind of a vicious cycle. So one of the things you want to do is use deployment and automation frameworks. They can help you mitigate process and human error risks. If you're deploying right now with a 20-step kind of manual checklist that your developers, your operations staff has to go through to actually make sure that they hit all the spots for your application to be deployed, that's problematic because they can miss steps or there's misconfigurations that can happen. So anything that can be scripted and automatically deployed will mitigate a lot of your risks on that front. And you want to also get comfortable with deployment. So practice using production-like replicas. Let your staff practice frequently and use AWS and use the advantages that AWS affords you to do that. You can quickly provision resources, and you can easily turn them off once you're done with those resources. So you can practice frequently and increase your confidence in deployments. And with that, thank you very much for listening to us. We're going to start accepting questions right now.